Good afternoon, everybody. For the first part of my talk this afternoon, I'm going to be talking about research objectives. So this will be taking off from last night's lecture by Dr. Siriban on research questions. No? So let's start with research objectives. So what I plan to do this afternoon is basically to define what research objectives are, and then we'll describe what a research objective should be, and then we'll try to write out your research objectives. So what are research objectives? So research objectives are clear and concise statements. So they are a statement declaring what you will be investigating and what you will be doing to these variables. So it's a very clear, it's sort of like a mission statement for your research objective. For your whole research. So what is the difference between a research objective and a project objective? Usually research objectives are very, very specific, and they tell you what variables are to be investigated and what you are supposed to be done. Whereas a project objective will be something like the impact of what's gonna come out after you do your intervention. No? So let's go back to research objectives. So basically, what we want with research objectives is that it guides you on the conduct of your research. So it keeps you right on track. Why do we have to state our objectives? Diba usually, if as a resident, usually we hear our consultants go say, oh, marami na tayong data, gawan mo na yan ng study. So actually, we do not really just make out a study based from what available data we have. So we definitely have to have the objectives first. So why do we need objectives? Because it establishes the focus of your study. And on top of establishing the focus of your study, it keeps you focused on what is relevant. Sometimes kasi, no, most of the time, what happens is this. When you have a database or you have an overflow of data, what you're focused on, you would suddenly think that maybe, oh, maybe what I can do some more with this additional data, or I can do another study with this additional data. So that is going beyond the scope of your study already. So it's very important for you to go back time and again to your objectives and stay in focus. So other than that, the objectives would direct your activities and resources towards your relevant goals. Therefore, it prevents you from wasting time and energy. So it really saves a lot of time and energy. And at the same time, it would also help you not to get lost. If another consultant would tell you, oh, you make another study and you see that it's beyond the scope of your objective, you can always say na, sir, ma'am, maybe I can ask a colleague of mine, another resident, to do that particular thing that you want. No? And then in the list of objectives, they also identify all the variables that are important to you and needs to be measured. So everything in the objectives are written clearly for you to follow. So when we write our research objectives, we always have to remember that we have to be smart. I know you are smart, no? You wouldn't be where you are if you're not smart. But here, in this context, what we mean by smart is that your objectives should be specific, measurable, achievable, relevant or realistic, and time-oriented or time-bound. So let's go through them one by one. So when we say we want your objectives to be specific, it basically answers the question, what is to be done, how will you do it, what are the outcomes we're looking for. No? So it lines out every aspect. Remember the research question that Dr. Siriban talked about, wherein you have your population, the intervention or exposure, the control, and the outcomes. So basically, those are the ones that are specifically written in these objectives. So as a result, you have a written statement that can describe what somebody else is going to concretely do if you're not there. So it has to be very clear. Sometimes what happens is that it's all in our minds, but it wasn't written properly. So another person who's supposed to go through and do your study will not be able to do so. So that would be a specific objective. Now let's talk about a measurable objective. So when you say measurable objective, it basically tells you, how do I quantify what I want? For example, what outcome do I want and how do I measure it? So for example, no, a very classic example is, what if I want to measure compliance? I can say, does this intervention make my patient more compliant to taking medications? So that would translate to, how do I measure compliance? So you can either measure it by days with normal blood pressure, kasi theoretically, if you take your medications properly, then you have days wherein your blood pressure is controlled. So you can measure it that way. Or you can also report it as daily logs. How many times, or did I take my medicine today? Yes or no? No? So how many people took their medication today and how many people didn't? So that could also measure compliance. So you don't only write in your objective to determine the compliance of subjects with this intervention and without this intervention. You have to write it in measurable terms. So when we say that your objective is achievable, it's basically, can I do it? It's basically, is it possible for me to do it? No? So you have to take a lot of considerations. For example, time, opportunities, logistics, as well as resources. So for example, I wanted to determine the ATAD1 gene mutation among children with delayed development. We don't have that capability here or even in NIH in Manila. So then, is it really achievable for us? If, let's say, I have to send it out and my patient has to pay for it, including the freight, then that may not be very achievable. However, if, let's say in Spain, one of the doctors there is doing a study on ATAD1 gene and he has the resources to do it, and I contact him and I am able to submit the samples free, then that would be achievable. The same thing as, for example, if you want to do a study on, let's say, trying to get out of school youth and check for their depression, or high school students and check for their depression. At this stage in time, when we have the COVID pandemic, we know that school will not be convened, and therefore, probably you won't be able to achieve your objective because there won't be any high school students in school at all. No? So this writing your objectives, you have to put into your context whatever is available to you as resources, as opportunities, as logistics, and then you decide if you're able to proceed with it. Now, very important when you make an achievable objective is that you have to make a reasonable target. Sometimes the target may be too easy for you. For example, you determine the blood pressure, tapos. No? Like if you want a certain intervention that eventually will help control the blood pressure, then you just report on blood pressure itself. But that would be too easy for you. Maybe you can add something like the quality of life or another outcome that is maybe lessen complications from hypertension, less chances of having stroke as an outcome, then that would be a reasonable target for you. So again, with your SMART objectives, it should be specific, it should be measurable, and it should be achievable. Next, your objective has to be relevant and realistic. So you have to start thinking, what would be the impact of your objectives? So if the impact of your objective is only on a small group, or that it's only very biological and not really clinical, then maybe that's not a good objective. For example, you want to make a study on a certain drug that would bring down cholesterol levels by about 5 milligrams per deciliter. No? So happy ka na if it brings down by 5 milligrams per deciliter. So that's your objective. So what's the impact of that particular objective? If your cholesterol level is extremely high and it brings it down by 5, based from your objectives, you are happy na. Pero clinically, it's still high, diba? So when you make your objective, you have to think of the actual impact to your patient population as well as to your practice. One question that we like to ask ourselves when we make the objectives would be, why should it be done? Why do I have to do this particular research, and why this particular objective? No, so you can answer it honestly, and it would be good if you take into consideration your mentor's inputs, because sometimes as trainees we only see what we're exposed to, especially in this limited exposure that we have in terms of the pandemic, where we generally have lower admission rates, the lower variety of cases. No? So it would be good to ask your mentors as well as your senior residents. Another consideration for a relevant and realistic objective is that it should be aligned with your institution or society's goal. So it would be good if you look at your institution or your society's research agenda, whatever is very important in your society. Like for example, the PCP may be encouraging or giving out research grants for let's say treatment on hypertension or on diabetes, or right now researches on COVID-19. No, so whatever is important in your society's research agenda, then you focus your objectives towards that. And then always think also, are you achieving too much? If it's not realistic, very common yung mga to improve the socio-economic state of residents in barangay ganon. No? So it's kind of very highfalutin Miss Universe type of objective. So again, you should kind of pull yourself back down to earth and see, come on, is my objective realistic or not? And lastly, it has to be time-oriented or time-bound. When we say time-oriented or time-bound, it's not only answering when will it be completed. Like for example, in our case, no, usually we want to finish it before we graduate because we can't graduate if we don't finish it, diba? So it's not only that, na parang my objectives has to be within 6 months, I finish it now, or within 8 months because I'm graduating na in a year's time. No, I have to write it up. No, it's not only that. You should also look at the objectives na when do I stop in terms of when this actual intervention or this actual research should stop. For example, if you're looking at prevalence of COVID, so this started out maybe sometime February, diba? The pandemic started to creep up on us sometime in February. So you started your study February na. So when are you going to get data? Up until when? No? Kasi like what they always say, COVID is going to be here with us. Maybe until we have a vaccine and have a very, very wide vaccination program, no? So that's going to take several years. So will you be, in your objectives, are you going to be talking about prevalence over the next 3 years, over the next 5 years, or you can come up with just in the first 3 months or in the first 6 months, no? The other thing, the other context of when do I stop is in the context of when do I stop doing the research. Like you have areas wherein if you reach your objective, like you reached your level of BP control of this much, then that's the termination. At the same time also, when you reach, let's say, mortalities over a span of a year, when you follow up survival of a new cancer treatment, then that is when you stop, no? So you also have to think about that. Kasi if you come up with objectives that go on for several years, if that is what you want, like the Framingham study, na several years talaga siya, then you have to write it down in your objectives. And you have to write out if you're going to come up with preliminary reports. So those are the SMART objectives. So what are general objectives? So general objectives are actually the main goal of the research. It's sort of like the mission and vision of your study. So it's basically stated in terms that encompasses all activities of the research. And in some cases, you may actually have 2 or more general objectives, no? Especially if you have like several studies under one umbrella major study. Specific objectives, on the other hand, are goals to achieve your general objective. So they actually describe fixed actions, and they're basically stated as a list under your general objective. So if you have a 2 or more general objectives, so for general objective number 1, you can have several specific objectives there. And then for general objective number 2, you can have another list of specific objectives under general objective number 2. No? So how do you write out your specific objectives? You actually expound on the details of the goals of your general objective. So for example, diba, you always start out with your research question, and then you convert your research question to a statement. For example, will proning help my patient with COVID-19? No? So you prone the patient. I'm sure you do that. So will proning help my patients with COVID-19? And then what you did with what Dr. Siriban told you, so you started searching for literature, and you found out, oh yeah, mukhang the literature is not really very clear yet, so I want to write a study on this. So you convert your research question into a statement to determine the effect of proning on patients with COVID-19. No? So basically, the general objective is to determine the effect of proning on patients with COVID-19. However, we have one problem there. When you talk about effect, what do you actually mean? Diba? Let's go back to SMART. Is this specific? No, it's not. No? Kasi the term effect, is it measurable? You don't know how to measure effect. No? Is it achievable? Probably, if you do your study, you can see the effect of that. Diba? So is it realistic? It is. It is relevant, of course, especially during our time. And is it time-bound? We don't know yet because it's not stated in the general objective. No? So we make our objectives smarter by writing in the specific objectives, for example, to determine and compare oxygen saturation levels. So the oxygen saturation levels, so that is a specific and measurable, as well as it's more time-bound and relevant for our research. No? The other outcome, other variable that we want is to determine and compare mortality rates among COVID-19 patients in the ICU who underwent proning to those who didn't. No? So mortality rate, it's measurable. Of course, you can see it. They die or they live. Diba? And then it's very time-bound because you'll stop monitoring when the patient dies, and you'll stop monitoring when the patient leaves the ICU and lives. Diba? So this way, you end up having SMART objectives already. Okay, so far so good, I hope. It's very hard to lecture without seeing everybody. So when you write out your research objectives, you always start out with an infinitive verb. Describe a unique case of, or to illustrate the theory on, or in a prevalence study, to collect samples of, and then in hypothesis testing type of studies, in intervention, you want to compare groups. And then in other studies, like in case control, where you want to see if there is an association between two factors. You can try to establish or to correlate. No? So these are examples to start out your research objectives. Then after you decide on what you want to do, so that's the pinaka direct way of telling people what you want to do, you follow it up with the variables and the population. For example, to determine the effect of an experimental drug, TTN 433, on blood pressure control among the elderly population. To compare mean arterial blood pressure among elderly receiving TTN 433 plus standard care and those receiving standard care alone. No? So in this particular research objective, it's very clear what you want to do, which is to determine or to compare what you're going to measure, which is blood pressure control or mean arterial blood pressure monitoring. It's specific on the population, which is the elderly, very measurable because of the blood pressure. And then it's very time bound because you're going to see whether you have good control or not. No? So that's how you write your research objective. Now, one of the things that we make a big mistake on when we start out to write your objectives is that we forget that our outcomes are not quantifiable. Our earlier example on compliance, no? We talked about compliance to medication. What if we want to talk about compliance of the hospital? Then we have the ISO audit tools. Or what if we say we want to see the effect of perampanel on improving seizure control? So what do we actually mean by improving seizure control? How are you going to measure that? No? So for example, you measure it by responder rate. So how many patients who took the medication had a 50% reduction in seizures as compared to those who didn't take the medication? No? So how do you operationalize these? No? You operationalize this by writing down in your definition of terms in your study. But when you write it down in your objectives, you already say to determine responder rates in the perampanel group as compared to the non-perampanel group. Yeah? So after writing your objectives, so you listed them down now. So you reassess the following. So first and foremost, are these the outcomes or variables that are relevant? So how do you know that they are relevant? On top of first looking at your own practice, looking at your own surroundings, are these relevant to us? Are these relevant to my society? Are these relevant to my institution? You also ask other people, do you think this is okay now? Do you think that these are the important variables that I have to measure? So the next thing is you have to determine, are these objectives within the scope of your general objective? So sometimes we tend to forget, like for example, no, if you, let's say, want a study on making a database, just a database on people who had stroke and hypertension within 1 year of each other. So a database would be sort of like a registry. You just list down how many people, maybe get their age, their sex, and that's it, and where they're coming from. Very basic, sort of like a census. So your objective is just that. And then when you present it, somebody would say, oh, why don't you add in treatment outcome? What about the medicines that were given to him? What about his maintenance medicine? So that would be beyond the scope of your objective already. You can just say, I'm just developing a database. I'm not into the outcomes. I'm not into the treatment effects. So it's just basically the database. So you have to look again if it's within the scope of your general objective. When you review and you find out na, I think I want something more, then you can always revise your objectives. You can either add another general objective or you just revise all your specific objectives. And of course, finally, are your objectives SMART? When you write down and you look at your objectives, you look at them as a whole, because you do not have to write every statement as SMART. Yung tipong it's specific, it's measurable, it's achievable, it's relevant, and it's time-bound na within 3 months, within 4 months. No, you don't have to write that. You look at it as a whole. You can write that in the general objectives, mentioning the time-bound or the time frame, and then it's not written anymore in the specific objective. But as a whole, when people read your objectives, both general and specific, you want them to say na, oh, Dr. So-and-so made smart objectives talaga. So as a summary and as additional caveats, no, a research study, always think, a research study may have 2 or more general objectives, and it's okay. And as a result, if you have 2 or more general objectives, remember, this means that you may have 2 or more research designs. And if you have 2 or more research designs, each design will have, and each objective will have their own methodologies. So basically, you're kind of combining several studies in one major study. It's okay if you can do it. Now, specific objectives should always be aligned with your general objectives. A lot of time we miss this out, no, as I mentioned before. And finally, a well-written and comprehensive list of objectives should be available after you write out your research question. But it should be available before you proceed with writing your protocol. Sometimes kasi, you already have a protocol in mind, or your consultant will be telling you already what to do. So basically, you have the methodology already, but you still don't have your objectives. The objective is like your life mission vision. So everything that you do is in line with that. No? So that's how important research objectives are. So basically, that would be my research objectives lecture for this afternoon. Thank you very much. And I think we should have time for questions now on this particular topic. Hi, Dr. Jason. Some students or residents add objectives as they analyze data. Is that allowed? Okay, so there's a question here. Just an observation, some students or residents add objectives as they analyze data. Is that allowed? Ideally, no. Ideally, no. Why? Because when we write down the objective, from the objectives, we design the methodology of the study. So sometimes when we come up with some other data that we want to analyze differently, then add another objective, we are not ensured that the methodology will give you a valid conclusion with that set of data. No? So for example, we're getting prevalence, just prevalence study. So you do a prevalence study, and then later on you realize, oy, baka we can do association like factors. Parang ang daming mga mas matanda, they're having this outcome. No? Just an observation from your prevalence study. Dagdagan natin. Let's establish an association between this and this. So basically, this is going to be a case control study. So when you do a case control, in my next lecture, you will find out that the sample size, the methodology, everything will be different as compared to a prevalence study. So when you come up and make a chi-square result, then the conclusion may not be valid because your sample size may be different. The way you identify the cases and the controls will be questionable. So then it's just not a valid outcome. So I wouldn't suggest that you do that. If you want to add in an objective, what you have to do is you'll have to go through the methodology, go through everything from identifying your respondents as if you're starting a new study and see if that fits with the data from your old study. If it does, then you can add in that particular objective. Now we move on to sample size and sampling design. So If you have your cell phones with you and your laptops with you, just make sure if you can get connected to the internet, then you can go along with me so that it'll be easier for you to understand. So let's talk about sample size estimation and sampling design. So for this particular lecture, I will start with reviewing basic concepts that in statistics that would lead us into understanding why we do this for sample size estimation as well as why we do this for sampling design. Next, after that, I will teach you how to calculate sample sizes for your particular study. And then after that, we will talk about sampling designs. So let's start with what statistics are, no? So basically in research statistics, we have the descriptive statistics, which is basically, you just describe the characteristics of your data set, no? When we say you have a data set, that means it's the data that you got from wherever you got it from, no? So you just describe it. And the thing with descriptive study is you have to describe it basically on what you have. You don't make extrapolations. You don't say, if I have the mean weight of this group of people, that's the same mean weight of another group of people. No, you just describe what you have. And you use measures of central tendency. These are the mean, the median, and the mode. And the measures of spread, which is central confidence intervals as well as standard deviations. The problem with descriptive statistics is you cannot make conclusions about a group outside your data set. So it's only limited. It just sort of like, it just paints a picture of what you have. That's it. Whereas inferential statistics would be able to derive conclusions about the population. So, diba, what we want is, if we want this data set on people with diabetes, we want it to try to apply to everybody who has diabetes as well, no? So that's when we do inferential statistics. The important thing about inferential statistics is that you use data from a small sample and then you test the hypothesis. The hypothesis is basically, does this sample that I have, is this the same as the population? So that is the basic hypothesis. So you keep that in mind, no? That is the null hypothesis. My basic sample data is the same as the bigger picture. That's the null hypothesis. So we test that. And then after we test that, then we make the conclusion. Is it true that our data is the same as the population, or is it false? No? So that's basically inferential statistics. So for descriptive statistics, the goal is basically, even if you get a sample from your population, unfortunately, you can describe only this small group. Of course, you can describe this big group, but you cannot say that this small group is the same as this big group, because you're just describing it. That's it. For inferential statistics, on the other hand, what we want to find out is if this sample is the same or representative of the entire population. So that's what we want. So does this small group truly represent the entire population? So that's the main goal of inferential statistics. Now, when we do inferential statistics, we have to consider several things in relation to sample size and sampling design. First and foremost, for example, you look at that circle of my sample at the lower end of the slide. Does this amount already represent that big circle? Or can I get a smaller circle and it would represent the population already? Or do I need a bigger circle? No? Kasi if you want to have a conclusion with the population, ideally, it's best that you get the entire population, every respondent, every person in that population. Unfortunately, that's not realistic. Diba? So then we get a sample from that. So now the question is this the appropriate number of sample? The other issue is, if you get the sample from, let's say, the top part of the population, is it the same as getting a sample from the lower part? No? So the question of how the sample was chosen arises. No? Because if you get only a sample, let's say, from an area of let's say, most people who are rich, then you only consider whatever conditions that they have, whatever outcomes or similarities that they have, and it does not truly represent the entire population of the area that you're trying to study. So why do we compute for sample size? No? So sample size is basically, what it means is the number of people that you will get. So why do we need to compute it? Because first and foremost, it's impossible to study the entire population, diba? Even if you want to study the entire population, it's too costly to study every individual. And this can be seen right now with the COVID-19 testing. Diba? Ideally, we want everybody to be tested. And we want everybody to be tested. And those who are positive, if it's possible to throw them into an island so that they get quarantined there, fine. And then you are sure that every person that you tested who are negative will be safe in your city. No? But that's impossible. And our government cannot afford to test every individual. No? So another thing is, some testing is inherently destructive. For example, if you want to do a study in neonates and you have to get, let's say, a genetic sample. In some genetic samples, you have to get 15 ml of blood. So for premature patients, you can't just get 15 ml of blood in all premature patients, diba? So you need a sample size so that you have only a representative of all premature patients. Then, of course, time limitations are present. No? You can't go around the whole city testing everybody, getting data from everybody. It'll take you, 10 years to try to catch everybody. And then we have to compute sample size because we want to increase the level of validity. So through sample size, we can manipulate the level of confidence as well as the power of our study. The terms level of confidence and power, I will explain to you later. So your sample size is basically the minimum number of respondents to be recruited for you to confidently give a valid conclusion. So it can be something as small as 1, or it can be something as big as thousands. But that would be the minimum number of respondents that you need to recruit. No? Because if you do not recruit that minimum number, then you cannot come up with a valid conclusion. So you might ask, Doktora, paano naman pag mga case series? Or we want to make a descriptive study on manifestations of COVID-19 among patients with diabetes. So is there a sample size? In this descriptive study, no, you don't need any sample size because it's just a descriptive study wherein you're following up. No? So it's sort of like a case series. So in that particular case, you don't need a sample size. But if you want to do estimations, if you want to perform inferential statistics, then you definitely have to need a minimum number that will give you a valid conclusion. And that will be your sample size. Now, let's go to the basic concepts. Now, these I'm sure are familiar to you, but you know, we may have forgotten it as the years went by, although I know bata pa kayo. So let's talk about accuracy. No? When we talk about accuracy, it refers to how close the estimate is to the true value. So for example, we got a group of elderlies and we got their mean weight. So if it is accurate, the mean weight that I got from this group of elderlies is the same as the real mean weight of elderlies in the population. Okay? So that would be accuracy. So unfortunately, accuracy will not depend only on sample size. Accuracy will depend also on how you measured it. For example, with the weight. What weight did you use? What weighing scale did you use? Did you use a digital weighing scale? When did you change the batteries? If you use a digital scale, or if you used a stand up scale, when was it calibrated? Who calibrated it? And then measuring methods. Who measured it? Did you use a bar, or did you have different midwives, or one time naman nurse? So if you have many different people doing it, then the accuracy will be questioned. But in our context regarding sample size, you also have to consider the chances of measuring. The more chances of measuring, that means the more people you measure, the more accurate you will be. Diba? That's common sense. So then that would lead to the concept of sample size. Now, let's talk about precision. So accuracy is when you got the exact estimate as the true estimate. Precision naman is when you have a data set, when you have different data from different respondents, how close to each other are they? So kunyari, if my weight is 63, the one beside me is 63.2, the other one is 63.4, the other one is 59.9. So more or less, we're in that group, no? So that will give you a picture that this group is homogeneous, that you have more or less a very tight group, no? So that would be good. Na it's more, what you got is more or less na in that area. The true estimate will be in that area. So when you see how close to each other the estimates are, that is the term we use is standard error. No? So we want the standard error to be small. So the smaller the standard error is, the more precise your data set is. But this is a word of caution for you guys. No? Do not confuse standard error from the standard error of the mean. When we talk about standard error of the mean, that means it's from all your estimates, you get the error, and then you get the mean, and the mean, how far away is it from the true estimate. So that's the standard error of the mean. Whereas standard error is just how far one reading is from the other. So precision is interpreted with standard error. When you look at your interpretation, the output that you get from SPSS or Stata or any other statistical tool, precision is seen as confidence interval. So you have confidence interval wherein you have sort of like the lowest and highest. The further they are from each other, the more heterogeneous is the group. The smaller your confidence interval is, then the more precise your group is. So this is a very classic illustration of accuracy and precision. So let's look at the leftmost dartboard first. Let's say your true population estimate is yellow, no? So if you look at the pink X's, all 4 pink X's are in the yellow. So this is accurate because all the pink X's are in the area of the true estimate. And if you look at the distance from one pink X to another, it's very close to each other. So they're precise. Now, in the middle dartboard, you can see that none of the pink X's are the same with the true estimate. So that is not accurate anymore. But they're all near one area. They're near each other. So they're still precise. Unfortunately, they're not accurate. In the last dartboard, they're all over the place. It's all over the dartboard, and none of them hit the true estimate. No? So this is not accurate, and it is not precise. In the context of statistics, no? So for example, this is the normal distribution curve or the bell curve for height among all people all over the world. So you would expect that on the right side, wherein you have the tall people, you would expect that you probably have the Caucasians there, whereas us Filipinos will be somewhere here on the left side. So let's say this red dot is the true estimate. Okay, that's the true height for Filipinos. Now, you got samples, you got other 5 Filipinos, and you measured them, and you look at all the blue spots. They're very, very close to the actual estimate. So it's fairly accurate, and they're all close to each other, so it's also precise. No? So you're able to get an accurate and precise statistics. Now, in this next scenario, this is the true estimate, and you have all of these blue dots far from it, but they're still close to each other. So it's precise, but it's not accurate. And lastly, this illustrates that it's all over the place. So it is not only not accurate, but it is not precise as well. So basically, what we want with inferential statistics is we want findings that are accurate and precise. And we can determine this by computing your sample size. Because remember, when we want precision, we want to determine like a very small confidence interval. And in the equation of computing confidence interval, we have to dictate the level of confidence as well as the power and the probability of having the disease and so on and so forth. No? So all of that will be mathematically supportive of accurate and precise outcomes. Talking about those equations is an altogether different lecture, but if you want us to have a discussion of that, that's okay. But I think it's beyond the scope of my objectives for this lecture. Okay. Now, the other important concept that we have to review is hypothesis testing. Remember, I said earlier, diba? I said that the basic theory is that one sample is the same as the population or another sample. They're the same. That's the null hypothesis. No? So what we want to do is, if you put an intervention, you want to see whether one sample is still the same as the other sample, or if you put the intervention in, one sample will be totally different na from the other sample. It could be better or it could be worse. Diba? So that's hypothesis testing. So it could be in the context of your sample is the same as the bigger population, or it's not the same as the bigger population. Or you have one group, is that the same as the other group? Or they're totally different. So always think, when we talk about hypothesis testing, always think always think in the context of the null hypothesis. No? The null hypothesis, or the H0, is assumed to be true all the time. No? So we usually state it as either the sample is equal to the population, or one group is the same as the other group. If they are the same, then we say there is no difference between the groups. Diba? Whereas the opposite of that, or the alternative hypothesis, is usually stated as the sample is different from the population, or one group is totally different from the other group. And that, in this case, we say there is a difference between two groups. There is a significant difference between the two groups, or there is no significant difference between two groups. No? So if you think about the null hypothesis, always think in the context of null hypothesis, that there is no significant difference in both groups. Then if you accept the null hypothesis, then you conclude that there is no significant difference between both groups. If you say reject the null hypothesis, then you say there is a significant difference in both groups. So you always have to, it's easier that way, not to think in the context of the null hypothesis. Now, for example, the two groups, if the testing, when you did the hypothesis testing, whether it's no difference, or there is difference, that is the real, true conclusion. Yun talaga yung in reality. Then you make the correct decision of either rejecting or not rejecting the null hypothesis. Diba? You make the correct decision kung tama yung pag-test mo. Pero, if yung pag-test natin is not true, it's false, nagkamali, then anong implication nun? We make the wrong decision. No? So, kunyari, you did the hypothesis testing, tapos sinabi mo na there is no significant difference, when in fact, in reality, there is a significant difference. So, ang nangyari doon, dahil nag-conclude ka na there is no significant difference, your decision is, this intervention has no effect. Pero actually, there is an effect. So, you make the wrong decision. No? So, I hope I did not lose you. This is it. When would then be the times where we make a wrong decision? There are two possible situations where we make the wrong decisions. No? First is, if the null hypothesis that there is no difference is true, diba? If the null hypothesis is true, then we do not reject. Diba? We say that there is no difference. However, we rejected it. So we make a mistake. This is what we call the type 1 error, no? Or the alpha error. If the null hypothesis is false, but we fail to reject it. Kasi pag false siya, dapat ni-reject mo siya eh. Pero hindi, you did not reject it. Then we make a type 2 error or the beta error. This is clearly seen in this table. Okay? So in this table, if you look at the top row, it says there the null hypothesis. So in reality, the null hypothesis can be true or can be false. Diba? If it's true, what do we do with the null hypothesis? We do not reject it. Diba? So then you see in the first top box, between the true and do not reject, that is the correct decision. Now look below that. If the null hypothesis is true and you make the wrong decision, you reject it, then we end up with a type 1 error, no? Or a false positive or alpha error. So yung error na yon, how do we correct that? So if you look at the chances that you reject it, diba? The correct decision, it's 100% you correct. But there is a chance that you might make a mistake. So that is the alpha mistake. So 1 minus alpha will be the probability that you will make the correct decision. And that is what we call the confidence level. So it tells you na parang what is the level na I will make the correct decision. You want it 95%? You want it 99.9%? Do you want it 90%? No? So as the author, as the one who will decide, you will be the one to decide with intelligence. No? You don't just say, para mas konti yung sample size ko, gawin kong confidence level ko 90 na lang. Hindi ako masyadong confident. Kasi when you read papers and then it says there the confidence level is only 90%, then it's not as valid as a conclusion that you want it to be. Diba? So the accepted confidence level is 95% and above. So that is the chance of you making the correct decision that you will accept or you do not reject a null hypothesis that is true. All right? So I hope that is clear. Now, if the null hypothesis is false, then what would happen is you have to reject it. Diba? So if you look at the bottommost box, that is the correct decision. So that is the true positive. So if the null hypothesis is false, then you make, and you don't reject it, then you make a mistake. So that's the type 2 error. So that would be na you have that you call the beta error. So now, di ba kanina we said, what are the chances that you will make a correct decision if the null hypothesis is true? Now, let's talk about what are the chances that you will make the correct decision if null hypothesis is false. This is what we call the power of the study. That would be the probability that you will actually reject a false null hypothesis. No? So, again, when we compute that, it is 1, the 100% that you will make the correct decision, minus the chances, the error of you making an error. Diba kanina, when we determine the confidence level, we accept a 5% mistake to maybe 1% mistake. Here in power, what is acceptable is kahit 20% mistake. So we often want the power to be around 80% to syempre, it's impossible to say 100%, but 80 to 90% is acceptable. So that is the concept of the confidence level as well as the power when we devise or we try to come up in a sample size for your study. Okay, so far so good. Now, let's start computing. No? So get your phones ready so you can download the app for EpiInfo. So let's say, no, for example, you want to determine the point estimate of a population. So for example, no, again, let's go to the elderly. We want to see the mean weight of the elderly population here in Zamboanga City. No? So, diba, like I said, it's always better that you really get all the elderly and then you measure it. That will be accurate and precise. However, that's impossible. So you have to get just a small number. So how many of that small number will you get? No? So I'm sure a lot of you have heard of the Slovin's formula. The Slovin's formula was devised for social science research, like when they do surveys, like, you know, the usual SWS poll, wherein they say out of 1,200 adult Filipinos, ano ang feeling nila kay Duterte ngayon, no? So that's basically what they use, the Slovin's formula. This is the Slovin's formula, where n, the small n, is the sample size that we want, but it's dependent on the actual sample size. And this is the equation wherein it's divided by 1 plus the actual sample size times the error level. The error level is the one wherein the opposite of confidence level. If the confidence level is how high is my chance of giving a correct decision, the error level is how much do I give myself to make a mistake, no? So in error level, in this particular situation, we put at 5% kasi our confidence level is the accepted 95%. So if you compute it, no? So let's say the population is 5,000 and then the error level is 0.05 kasi 5% lang. So you end up with 370.4 people. But of course, there is no 0.4 person. So you round it up to 371 people. So out of the population of elderlies, you will get 371 people. So yeah, that's kind of reasonable, diba? Now, the problem with Slovin's formula is it does not take into account the rarity of the event. For example, sige, one of you is going to do a study on people with hypertension. So same barangay, 5,000. And then you use the Slovin's formula. And then you get 371 persons with hypertension. Because hypertension is very common, I would expect that you'll be able to get this much people in about a week's time. Diba? Whereas if one of you was assigned naman to do, let's say, quality of life among people with Guillain-Barré syndrome. And we know that Guillain-Barré syndrome is only about 0.4% prevalence. And you need, with the Slovin's formula, it also computed for 371 persons. So when will you finish your study when will you be able to recruit 371 persons in that 5,000 person who will get Guillain-Barré syndrome? It's close to impossible, diba? So that's a problem with the Sloven's formula. They don't take into account the rarity of the event, such as in our health statistics, no? So what's the solution for this? Okay, so here we go, no? So for example, I'm going to teach you now on how to compute for a population survey, no? So let's say, spin off from the Guillain-Barré syndrome, no? You want to determine if the true value of Guillain-Barré syndrome, a true prevalence is 0.4%. No? So you decided that the design of the study will include a random sampling of residents and that your margin of error will be plus or minus 5 from the true prevalence. So in the barangay, there are 5,000 residents. So it's basically the same scenario as the previous example. No? So what do you do? If you use the Sloven's formula, like what we showed earlier, you need 371 people. Pero hello, you won't be able to get that much, diba? So you need a better equation. And where can you get a better equation? Here in EpiInfo, CDC EpiInfo. It's a free downloadable app that is used for epidemiological research, no? So it looks like this. The icon looks like that. So that is what you're going to download. Now, if you click on that, it opens up into this interface. You can either enter the data, analyze the data, or you use the StatCalc. Entering data and analyze data, maybe Dr. Jelani will be teaching you in how to use that, because in basic epidemiological studies, you can actually use this app already, wherein you can enter the data as you go along. No? So this is a very handy tool. But for our discussion right now, again, focus on our objectives. We're going to click on StatCalc. So when you click on StatCalc, you will be able to see download the sample size and power. So for this particular example, since this is a population survey, you want to survey the population, then you click on population survey. And when you click on population survey, this comes out. This is the interface, no? So if you read population survey or descriptive study for simple random sampling, leave design effect in clusters equal to 1. No? So we'll explain that later. Now, what I did here is, look, I entered our parameters. So population size, 5,000 residents, diba? The expected frequency of Guillain-Barré is 0.4%. The margin of error is 5%, plus or minus 5%. So what is the margin of error? The margin of error is how much you are willing to make a mistake, either 5 points above or 5 points below the true estimate. If you want to be more accurate, no, then you can make your margin of error smaller. It can be 1 or it can be 0.5, no? So it can be more accurate into that sense. But 5% is acceptable already. What is the design effect? The design effect basically means is the ratio of the variance, kumbaga, the ratio of how variable your data set results will be if you use a random sampling design or if you use a convenient sampling design. So if you're going to use a random sampling design, your design effect is 1, because the design effect is the same as the random sampling design, because that's the ultimate, that's the standard. But if you want to use convenient sampling, no? So because of convenient sampling, later on we'll be talking about the biases of that, then the design effect is not equal to a random sampling. So the design effect will be higher, no? There will be more flaws, kumbaga. So the more flawed the design will be, the higher will be the number. Now, what are clusters? Clusters is different groups where you're going to get, no? So in this example, we want to get from one barangay as a whole. No? So you have only one cluster. So why do we say that design effect and cluster is equal to 1 if you have simple random sampling? Because in simple random sampling, you already take the whole as the population. No? So you only have one cluster, one big group. So then the design effect is also 1 because you also use random sampling. No? So then it's left as 1. As a result, you will come up with a table with different confidence levels. No? So you have confidence level from down to 80% to 99.99%. And then you can see how many sample respondents you need for your cluster size. So since you only have one cluster size, then you only have 6 in the middle row. The total sample will be including all the clusters now. So since you only have one cluster size, then you only need 6. So if you want to see the true prevalence of Guillain-Barré syndrome in the barangay, then you need, of 5,000 people, then you need to randomly select 6 people from this barangay. And that will give you already a 95% level of confidence with 80% power. No? So, see, it saves you time, it saves you energy. Pag nakahanap ka ng 6, you go directly to their houses and then that's it. No? So that's the beauty of computing for your sample size. Now, let's say in your barangay, you have 5 puroks. No? 5 puroks with sort of like a familial predisposition, ang alam mo, for certain autoimmune diseases. So now what you want to do is you want to get equally from all 5 puroks. No? Hindi lang yung tipong, what if from that whole barangay, because of random sampling, you end up with everybody coming from one purok, then parang feeling mo it's not fair, it's not right. So you want to get from 5 puroks. So look here. Look at the clusters. I changed it to 5 because there are 5 puroks. So I'm going to get ilan-ilan from 5 puroks. And the design effect became 2. No? Because this is not going to be sort of like a random sampling. Now, this is more of a cluster sampling na. No? So the design effect, I changed it to 2. Basically, because after I do it by cluster, I want to do random sampling. So the design effect is not that bad. So I made it into 2. And look at how you ended up with. At 95% confidence interval, you need 3 persons per cluster size. So one cluster will have 3 people. So from Purok 1, you get 3. From Purok 2, you get 3. From Purok 3, you get 3. So you end up with 15 respondents as compared dun sa random sample na you only have one cluster, you only needed 6. No? So this is because if you do cluster sampling, you tend to have biases towards the location. For all you know, maybe one area might have exposure to pesticides, which increases autoimmune conditions. No, so it takes into account all of this variability. That's why you end up having more respondents. Remember, the more you have, the more accurate and precise your results will be. Okay. Now, basically, from that interface, that equation for the population survey, you need to know the population size. So where do you often get the population size? From the barangay, from the city, from the PSA statistics. So we look at the census. Now, the problem is you're not sure if that is 100% correct. But more or less, if you look at the most recent census, then you can use that. No, it's okay, because when you write down your sample size computation and explanation in your paper, you basically write all your assumption and how you got your data. Then we as readers will understand if it's not 100% accurate. Diba? Now, the probability and prevalence of the disease or the condition being investigated, diba? Yung 0.4% of the Guillain-Barré syndrome, that is basically from previous studies. So, for example, you find previous studies na prevalence, and then you look at the prevalence sa northern hemisphere is higher as compared to the southern hemisphere or dun sa equator. So, if I have a study on Norwegians wherein their prevalence of Guillain-Barré syndrome is, let's say, 2%, as compared to, let's say, Singaporeans, wherein the prevalence is 0.4%, then I choose Singaporeans because they're closer to us, no? Now, just in case you don't know, you absolutely don't know the prevalence, and you can't, in your literature search, you cannot find any, then it's safe to put the probability at 50%. So remember, if you're not using a random sampling technique, always change your design effect between 2 to 5. No? It depends na on you, on how bad you think your sampling technique will be. Now, let's move on. So tapos na yung population survey. No? Now, let's talk about two proportions. When we say two proportions, a proportion is a percentage. So we're talking about people. We're talking about how many patients improved on this drug versus how many patients improved on this drug. Or how many people smoke in this group of person and how many people smoke in this particular group of persons. No? So these are two proportions. So this formula is used for studies that compare proportions from two different groups. For example, you have an intervention, drug Y. If you gave group 1 has drug Y, group 2 has no drug at all. No? So two different groups. And you compare proportions. You compare how many people improve here and how many people improve here. Then you can use this equation. Whereas it can also be na you follow up. It's a pre and post interventional design. So you only have one group where you have pre and you have post. So it's still two groups. The same people, but group 1 is these people did not receive the drug, and these people, group 2 is these people already received the drug, but they're still the same. No? So it's still two proportions. So what you do is you go back to StatCalc, and then what you do is you click in the cohort or cross-sectional study. Okay? So let's have two examples. Since we have two scenarios kanina, in the previous slide I talked to you about. So let's have example 1. For example, you want to do a cross-sectional study on smoking among males and female patients with diabetes. All of them have diabetes, but you want to determine, to compare males versus females in your OPD clinic. No? So let's assume you want a two-sided level of significance. When we say two-sided level of significance, it means that it can either be one is better than the other and the other is better than the other. No? And not assuming that, pag one-sided yun, males will definitely be more smokers than female. It's a given. Then that would be one-sided. Pero if you don't know, malay mo, mas grabe na yung mga babae ngayon and there are more smokers there, then that would be a two-sided level of significance. So you assume that it's 95%, you dictate that you want a power of 80%, and based from a different study, let's say 10 years ago, somebody else made a study in your institution and said that males with diabetes, 65% of them smoke, while women with diabetes, only 48% smoke. So what will be your sample size? So if you use this cohort or cross-sectional equation, you will come up with this interface. So what I did, so we wanted the two-sided confidence interval to be 95%. The power is 80%. Ratio means how many men is to women. No? How many do you want? How many men per woman or woman per man you want to recruit? No? So in this particular case, I want a ratio of 1. That means if I get one male, I will match with another female. So that's 1:1. No? So that's 1. Now, you have to listen carefully, ha? Kasi this is the part wherein a lot of my students get confused. When you say percent outcome in unexposed group, in the context of our example, no, what is the outcome? The outcome that we're looking for is the smoking, di ba? So it is either 65% or 48%, correct? Kasi yan yung prevalence of smoking from a previous study. So, alin dyan ang exposed and unexposed? So if you look at the unexposed, you randomly choose. No? Pwedeng yan yung male, pwedeng yan yung female. So what I did in that context, para hindi ako malito, unexposed for me is unexposed to the Y chromosome. So that means wala kang Y chromosome. So percent outcome in unexposed is female. So that's 48%. Whereas the percent outcome in exposed group is you are exposed to the Y chromosome, therefore you are male, then I put the 65%. You will notice, no, if some of you were able to download and you put in those data, you will notice that the risk ratio and odds ratio will automatically change when you move the bar on the exposed and unexposed groups, no? So that's okay because it automatically computes for that. However, in some cases kasi, previous studies might not give you the percentage, the proportion of how many percent males or how many percent females. What's gonna happen is they already give you the risk ratio or the odds ratio. In that case, what you can do with this particular app is you can just move the exposed group or the unexposed group. You choose anyone, it doesn't matter, until you see your odds ratio or your risk ratio change into what was available in the paper. No? So once you click already, kunyari the paper said 2, then when you moved it, umabot na sa 2, stop ka na doon. Disregard kung ano man yung number dun sa percentage outcome. Basta meron ka na yung correct na odds ratio. Then what's going to happen is they're going to have this table wherein they have 3 different columns of results, no? So you have Kelsey, flies, and flies with continuity correction, yung CC, no? So, anong difference nito? Professors Flies and Kelsey are mathematicians who came up with the equations for getting sample size for comparing two proportions. Ano yung differences nila? They actually just have differences in terms of the Z. It's a constant. It's a constant number that we have in the equation. Doon lang sila medyo nagkakaiba. But if you look at the numbers, hindi naman masyadong nagdi-differ. I often choose the flies because that's the one with the lowest number of respondents. So if you look at the flies, the encircled part, so the exposed to the Y, so I need 133 males and I need 133 females to make a total of 266 respondents. So my sample size is 266 with 133 males and 133 females. Okay? So that is in this situation wherein you have two separate groups. What if, in this example, second example, you want to do a pre and post intervention study? Okay, for example, I want to give vitamin D supplementation and look at bone health of individuals with obesity. So what I did was, I get obese people, I measure their bone health, then I give them vitamin D, and after a few months, I check their bone health again. So this is a pre and post-interventional study. But technically, if you think about it, this is still two different groups. The group before the vitamin D supplementation and the group after. Kahit same person siya. No? So, I read a paper that said, in one study, the baseline bone health, 50% of them had poor bone health. And then after they gave vitamin D, 40% na lang ang may poor bone health. So there was an improvement in 10% of the people who took the vitamin D. So what do I do? No? So if you look at this, so two-sided confidence interval of 95%, the power of 80. Now, the ratio to unexposed to exposed is 1 because basically I'm using one person lang, di ba? The percent outcome in unexposed. So in this context, what are they supposed to be exposed to? Vitamin D, diba? So pag unexposed ka sa vitamin D, that means that's the pre-intervention. So before the intervention, it's 50%. Then in the exposed group, after the vitamin D supplementation, it's 40% na lang. Okay? Same thing as my explanation before, if the study gave you odds ratio instead of the percentage of people, then you can use the odds ratio and then you play around with the arrows na lang, no? So you end up with this table that will give you 776 respondents. No, 776 because you have 388 before and you have 388 after. No? So, for example, if your population characteristics are not equal, for example, in the OPD clinic, there are more females than males. Then what you do in the ratio, you can change it to 2:1 or 2, no, or 3. Then you have more females to recruit than males. Okay? Next. So that's finished now. So we talked about if your study is a population survey, your sample size computation should be population survey. If your study is about a cohort or a cross-sectional study between two groups, then you use the cohort or cross-sectional. Now, what if we want to establish already if one proportion is equal to the other proportion? It's usually if the odds ratio is 1. So in case control studies na to, no? So in case control studies, this is what you click, the unmatched case control. So this kind of, look at the interface. It's very similar to the previous one, no? But let's look at the example so you can understand very well. So let's say there is an issue about individuals with previous autoimmune conditions having severe COVID symptoms. No? So for example, if I have had SLE, then most likely will I be having severe COVID symptoms as compared to somebody who does not have SLE. No? So that's maybe an issue. So based from available small study, 40% of individuals with severe COVID disease, so those with severe COVID disease, these are the cases, no? They had a previous history of autoimmune conditions, while 15% of individuals who had only mild or asymptomatic COVID, these are the controls, had a history of autoimmune condition. So because of this, what will be your sample size? So let's say the two-sided confidence interval is 95, power is 80%. So your ratio of controls to cases, I want 1:1. No? I want 1 severe COVID versus 1 mild or asymptomatic. So among those percent of controls, these are how many percent of mild to asymptomatic COVID had exposure to autoimmune problems. It's only 15%. For those with severe COVID naman, there was 40%. Diba? So again, it automatically computes for the odd ratio and you end up with this. You need 98 respondents. Since I wanted 1 control to 1 case, then I need 49 severe COVID cases versus 49 asymptomatic or mild COVID cases. Now, this is my problem. Like for example, for those here in Zamboanga City, um, how many severe COVID cases have we had? Have we reached 49? Probably not, because we know that severe COVID cases is not as many as mild or asymptomatic, diba? So baka we will have a hard time, or most likely we will have a hard time getting 49 severe COVID cases. No problem with the 49 asymptomatic or mild cases. No? So what do we do now? No? So when you end up like that, oh gosh, this is going to be difficult. Is this achievable? Yes, it can still be achievable by manipulating your assumptions. So what I did, look at the ratio of controls to cases. What I did was, because I know there's way more mild or asymptomatic COVID cases as compared to the severe, I said I want for every 10 mild or asymptomatic, I have one COVID case na severe. No? So with that, look, I will end up with a bigger number lang, no? 255. But I will get 231 mild or asymptomatic cases versus only 24 severe COVID case. So it's more doable. It's more realistic, diba? So you can actually, ang term namin dyan is laruin natin yung numbers. No? Pag nakita namin, oh, mukhang very impossible tong sample size natin. Sige, laruin natin. And so you can tweak it a bit into an acceptable level naman para it won't be very hard for you to recruit that number. All right? Okay. So, wait. So far, don't be confused. So far, that EpiInfo app is very useful for population proportion study. So if your outcome in your objective is number of people, no, you want the proportion, percentage of respondents, percentage of patients, the number of people, you use this. You use EpiInfo. Now, what if my outcome is a mean body weight, mean blood pressure control, mean cholesterol levels, no? Then you cannot use EpiInfo anymore because EpiInfo doesn't have that. I personally use this, Stata. Actually, Stata is a software. It's a program for statistical analysis. And what's nice with Stata is if you look here at the bottom, you have power and sample size computations for both proportions, yung tulad sa EpiInfo, and for means. At the same time, it also has the capability if you want repeated measures. For example, if you want to check for the first month, ano ang outcome, second month, third month, fourth month, fifth month, no? So for repeated measures, it can also compute for that. If you want survival analysis, the Cox proportional hazards model, it can also compute for sample size for that, no? So since this is a statistical software, it has more a robust power, no? Unfortunately, you have to buy Stata. So what I did for you guys is I use a different free tool online, the Statulator. No? You can go to statulator.com for this. The Statulator, it's a free, like it's online, so you can compute it online. No? So let's talk about computation for means. So example, you want to estimate the mean weight of elderly individuals in Zamboanga City. So it is reported from a previous small study that the standard deviation from their data is 5.5. So you want to have a margin of error of about 2. What is your sample size? No? So what is standard deviation? Diba, standard error is difference from one estimate to another. So it talks about precision. Standard error of the mean naman is how accurate is yung mean mo from the true mean. Standard deviation naman is how far away from the mean is yung mga data sets mo. So yung standard error is how far away from each other. But if you want to see how far away from the actual mean, then that's a standard deviation. And standard deviation explains the variance of how big plus minus from the mean yung mga data na nakuha mo. No? So the smaller the standard deviation then, the more homogeneous it is. Okay? So margin of error, remember what margin of error is? The error is how far away from the true value it is. No? So you want 2. So it's kind of accurate. So if you use the statulator, if you use the statulator, there on the left side is the sample size icon. So you click on that and look, they also have proportions. Pero when I looked at the proportions, it's way too complicated. It's better to use EpiInfo if you want to use proportions. So what we're going to use is for the means. That one, no? You can estimate the mean, you compare 2 independent means, which is independent samples t-test, or compare pair differences, which is dependent t-test yung gusto mong gawin. And then, so ano yung sample size mo, no? So, if you look at the interface, you will have to dictate the level of confidence, the expected standard deviation, and the margin of error. So for example, you have in our example, the expected standard deviation is 5.5, and the precision or margin of error that you want is 2, then you only need 33, no? So you input properly what you have information available, then you only get 33. Random sampling to. Now, if let's say the standard deviation is bigger, 10, diba? The smaller it is, the variance, the differences among all the data set is smaller. Whereas I changed the standard deviation to 10, so it's more heterogeneous, then you end up with having a sample size of 100. Because since it is more variable, then you need a bigger sample size to try to be more accurate. Diba? That's the logic behind it. Now, if let's say I want to be super accurate, so my margin of error, I will put to 1. No? So standard deviation is still 10 kahit homogeneous siya, pero I want to be as accurate as possible. So my margin of error is 1. Then look at the sample size. I'm supposed to get 388. Mas malaki. Because like I said, logic says if you get more, then it's like hitting the lotto. If you buy more tickets and you make taya more, the chances of winning is, the chances of getting the correct true sample size is going to be higher, diba? So basically that's it. So that's how you compute for your means if you want to estimate a mean. Now, you want to compare 2 independent groups, no? So for example, one group is receiving drug Y and will have a mean oxygen saturation of 99%, while the other group receiving standard care will just have a mean oxygen saturation of 93. The estimated standard deviation is 1.5, no? So in this one is independent samples t-test, diba? So I want to do an independent samples t-test. So what is going to be my sample size? Now, the problem is, in a lot of studies, I noticed, especially in our local studies here, I noticed that they don't write the standard deviation. They often just write, you know, this group and that, this mean and that mean, ganon, no? So you can actually compute for standard deviation from the data that you have, like from the difference of the means, like 99% ang mean 1 and 93% ang mean 2, the difference is 6, then you divide it by 4 and you end up having 1.5. So that's an estimated standard deviation. So you can do that, no? So you choose the equation for comparing two independent means. And then you click on expected means because you already have the expected means. So if you look here, the mean of the reference group, which is standard care, is 93. The mean of the test group is 99. And the standard deviation is 1.5. And look, you only need 1. Yes, this is real. This is for real. It can happen. Why is it 1? Because the difference between 93 and 99 is big already. Kumbaga, this previous study already showed that this is extremely effective. So you just only need one person to say na, yeah, this is effective, no? If you don't believe that, look, in Stata, I did it. So in Stata, they use the term two-sample comparison of means. So you have two independent samples and you compare the means, no? So mean 1 is 93, mean 2 is 99. The standard deviation is still 1.5. If you compute it, the nice thing also about Stata, you can either decide to compute the sample size or compute the power. And if you compute it, it's really 1, no? So you really just need 1 for each group, no? Now, what I did is, if I change the reference, no? Let's say from 98%, it can reach up to 99 only. So the difference is very small, no? So look, the sample size will be bigger. Because since the difference is very small, I need more people to really do it again and again and see if there really is a difference. No? So I use data, it's really the same. No? You need 36 people. Now, if you want to compare the drug Y that we talked about, no? But you wanted to give it as a pre and post interventional design. So this means this is dependent t-test na, no? So this is dependent samples. Then you compare paired differences. In Stata, we use the term one sample comparison of means because there is only one group, no? So here, you compare paired differences because it's pre and post. So from here, you can see if you input the mean and standard deviation of the difference, the mean of the pair difference is the mean of yung mga differences nila. So for example, if it's 99 minus 93 divided by 2, then you'll end up with 96. No? So here, I inputted 96 and the expected standard deviation is 5. Then I just need one person. No? If, for example, no, your study did not tell you, did not show the means or did not show the standard deviation, and you don't know what to put in there, you can actually choose the option to put the effect size. The effect size is how big an effect you want to find, no? Effect sizes are from 0, no effect, to 1, really big, perfect effect, no? So let's say in this example, I put the effect size in the middle lang, 0.5. So if it's 0.5, then I just need 34. If I want to detect an effect size of mababa lang, 0.2, then I need 199. Here, oh. Then I need 199. What if I want to see an effect size of 0.8? It's very high. So I only need 16. So why? It's the same logic as before. Yung dahil the means are very far apart already, the effect you can really see that there is a difference, then you only need a small size. Compared na, pag magkakapareho sila, almost the same, you need a bigger sample size to establish that there really is a difference, no? So this is sample size computation for means. Okay, so after you computed for your sample size, you always have to add about 10 to 20% of the number for dropouts or loss. No? Kasi the ones that you compute, like the last one, you only need 16. The 16 is the minimum number. Minimum number. And what if biglang nag-drop out siya? What if hindi siya nag-follow up? What if ang titigas ng ulo ng mga tao tapos they don't follow up? So more or less, you know already your population and you think, ay nako, maraming tamad dito. I'll add 20%. And what is 20%? No? So that will be around 4 more people. So in business 16, then you recruit a sample size of 20. Para kahit meron kang loss to follow up, meron kang mali yung pagkuha ng data and you have to drop the data, you're still within the minimum number that you need. Okay, so for sample size computation, remember we talked about proportions, we talked about means, and then we talked about for each proportion and mean, we talked proportion, we use EpiInfo. For means, we use Statulator as an example. And then for each group, we have estimating the entire population, estimating entire mean. Then we have comparisons, and then we have case control for the population. Different equations yon. All right? So far, so good? Okay, so after you compute for your sample size, the last part of my lecture is how do I recruit them now? Diba? So I need 16. So how do I go about getting it? That is what you call your sampling design. No? So you already have your sample size. Now you decide how to get it. So the last part is sampling design lecture. This is fast na lang. So let me tell you a story. No? Back in 1936, there's this magazine called the Literary Digest. The Literary Digest is a very, very famous magazine. What it does is for every presidential election, it makes a poll. It makes a poll and then it predicts kung sino yung winner. And for the past several presidential elections, they always predicted that the Republican will win. So this guy is Art Landon. He's Republican. And this guy is Franklin Roosevelt. He's a Democrat. And since Republicans like President Trump, diba, they're very white supremacist and everything like that. So all the ones who won before has been Republicans. So eto, for the 1936 presidential election, what they did was they made a poll. And you look, Landon in that poll won by 1,293,669. Whereas si Roosevelt was 972,897. So it was a very big difference. However, when the actual elections came, Roosevelt won. Roosevelt became their president. No? So because they made a mistake, this was such a big mistake talaga for this particular magazine, they ended up closing shop. As in, bumagsak talaga yung magazine na yun. Nobody believed them anymore. So what went wrong? What went wrong? Because every time na lang, they predicted that the Republican will win. So what happened was, what they did, they got the sample, they got 2.3 million respondents. So 2.3, the population at that time was 123 million. So 2.3 million, not so bad, diba? Not so bad. The sample size seems to be okay. However, they got the respondents from telephone directories and vehicle registration lists. So they went to LTO, they went to PLDT, they looked up Smart, they looked up Globe, and then they got the names. The problem is, those who have telephone directories, those who have vehicles, what do they have in common? They're the richer ones. They're the richer ones, and they are the white Americans most of the time, diba? So apparently, their sample reflected not the entire population of the US at that time, no? So ang nangyari dyan is they did not take into consideration the blacks, the African Americans, the Asians during that time, which was a small population, who would not have telephones in their houses and who would not have vehicles at that time. No? But in the end, they still went out to vote. So as it turned out, Roosevelt won. No? So that is a very good example of a wrong sampling design. So the importance of having a proper sampling design is it reduces bias. In our example earlier, there is a bias, what we call Bergson's bias. Bergson's bias or Bergson's fallacy is basically a bias wherein by the time they enter into the survey or the study, their own characteristics already made an effect on the outcome. For example, no, in this particular case, the ones that they chose were already rich and were already more Republican to start with. So they only, in effect, they only reviewed or polled Republicans. And syempre, if you polled Republicans, Republicans will win, diba? So in Bergson's bias, in our context, this is often also called admissions bias. For example, especially tayong mga residents, no? Tayo daw. Especially kayong mga residents, you often have studies among patients admitted in this hospital or among patients seen in the OPD. Diba? So diabetes patients seen in the OPD. The bias there is those who go to the OPD are basically people with diabetes who are more compliant as compared to the people with diabetes who don't go to the OPD or don't go into the doctor. So the outcomes, so if you're doing a study on compliance to medication, the outcome, of course, will not be reflective of the entire population of people with diabetes because you did not take into account those people who have diabetes who are not very compliant in checking up. Gets? The same thing as if you're doing a study on outcomes, no? On outcomes, let's say, of a community intervention on a certain disease. And then you get only people who eventually get admitted in the hospital. So you look only at people who come into the hospital and they're already in the severe condition. Syempre, your outcomes will be bad. And your condition and your conclusion will be the community intervention did not do anything good. No? So that's already a bias. So how do we correct that bias? We correct that by revising our sampling design one way. And of course, another way is your research design, which we can talk about in some other time. There's also the self-selection bias. The self-selection bias naman is a bias wherein you either select people that you think will be the same as to what you're thinking. No? So ito mukhang okay to, mas maganda tong ipasok sa study. Mga ganyan. No? Exclusion bias naman, ganon. You exclude people who should have been included, like those diabetics who do not go to the OPD. They should have been included if we're talking about, let's say, a compliance to a particular medication. Healthy person bias naman is you only get people who are healthy. Then your outcome tends to be nicer. No? Or you get people who are younger, then the outcome becomes better. Overmatching bias naman is when you try to match each and every condition, let's say outcome, smoking, and let's say a person with males. In our culture, males are known to be more of a smoker, but we want to match everything the same, no? So you want to match one male to one female. So in those groups, where you match one male to one female, the outcome on the effect of smoking will be different if you were male or you were female. No? Again, these can still be corrected by your research design, by choosing the correct sampling design, and by choosing the correct statistical analytical tool. And of course, finally, there's a survivorship bias. If you only consider, because there are some studies, no, if the patient is lost to follow up, they drop the data already. And what if they got lost because they died? So that's a bad outcome, diba? Or what if they got lost because they experienced adverse events? Then that is also an adverse outcome, diba? So if you counted them, even if they were lost, and you counted them as a bad outcome, then you remove survivorship bias. Because if you remove them, ang lumalabas lang dun sa study mo are those who ended the study na maganda. They're compliant, they survived, and so on and so forth. No? So you sort of dropped out everybody na sana we could have gotten information from. No? So if we choose the proper sample, then we remove all of these biases and produce a more valid result. So sampling methods, no? These are the basic sampling methods. And if you read other papers, it's actually a sort of like variety or a little tweaking on any one of these. No? So let's start with random sampling. When we say random sampling, each and every person, individual, household of the population can have an equal chance of being chosen. And this can be done by lottery, by random number table, or by computerized random sampling. Ang lottery, before, di ba, yung bola na ganun-ganun lang. So what if you're going to do by lottery, we have online lottery algorithms na. Or you can talk to your IT person to make an online lottery algorithm. Ano ang online lottery algorithm? The online lottery, alam mo yung minsan in some pharmas, like when we attend their RTDs, they will have sort of like raffle. So they'll have a raffle of some stuff. And then as you enter, they enter your name. And then you have so many names. And then later, makikita mo yung parang bilog-bilog na ting, 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 and then suddenly one name will come out. No? So that's basically an online computerized lottery or raffle. So you can do that. So kunyari, you need 16 out of 100. So i-enter mo lang yung 100 names in that from your population. And then pa-lottery mo lang siya ng 16 times. And those are the names that will come out. Okay? The other way to do that would be a random number table. So a random number table is like this. No? Nakakahilo siya. So what we do is you look at the row, the topmost row. So you have sets of numbers. And then you look at the column on the leftmost side. So you have from rows 1 all the way down to 50, no? So that's what the column shows. So what you do is, for example, you need only 16 people, but you have 100 people to choose from. So 100 is 100, 3 digits. So you look at the last 3 digits of each set of number. And before you start, you already decide, I'm going to start, you don't look, I'm going to start at column 8, line 15. So you look at column 8 and line 15, and you end up with 81056. So the last 3 numbers, kasi 100 lang naman from 0 to 100, diba? So 056. So number 56 in your list of person is the first person that you will choose. And then you decide, do I go right or do I go left? I'd say I'd go right. So going to the right, it's 97735. So you choose number 35. So that's the next person. So that's how you use the table of random numbers. But there's something easier. Ay, sorry. Why is this like this? Wait, ha? Ah, sorry. So there's something easier actually, no? So this is a random number generator. So for example, let's use the example of our Guillain-Barré scenario. The prevalence rate is 4.4% and you need a sample size earlier, di ba? The previous sample size that we got is 6. So we only need 6 people. So how many random numbers do we want? We need 6 people. So here, you type that in. And then the minimum value, since our barangay has 5,000 residents, so syempre, our minimum value is citizen or resident number 1, and the topmost value is 5,000, resident number 5,000. Now, allow duplicate entries, false. No, I will not have duplicate entries because I need one unique person at the same time. No? Now, you click calculate and this will come out. So it gives you a list of 6 numbers. So you get resident number 435, resident number 788, resident number 1055. So they are the ones that you will go and ask for your study. No? So this is an easier way to get respondents by random sampling. So that's how you do it. Another way, so that was StatTrek. No? Another site that is I really like is Research Randomizer. No? A Research Randomizer, again, same scenario. How many sets of numbers do you want to generate? I only want 1 set. And then I want 6 numbers because I need 6 respondents. So the number range again is 1 to 5,000. Do you want the numbers to remain unique? Yes, because I don't want any double entries. And then I want them to arrange the numbers from least to greatest para hindi ako malito, and I will place markers. The place markers is that they will write patient number 1, patient number 2. So more or less, you know, you don't count the numbers 1, 2, 3, 4, 5, 6 anymore. No? So if you click on this one, the result is P1, patient 1 is number 1,273. So in my list of people in the barangay, hanapin ko, sino si 1,450? Siya yung lalapitan ko. Sino si 1,753? Siya yung lalapitan ko. So on and so forth. So yun yung lalabas dun sa random sampling. So this is all free and you can use this, no? The next sampling method is a systematic random sampling. So what you do is you obtain a sampling frame. A sampling frame is a list of all your possible respondents. Then from the start, you decide na from the nth number of participants to enter the study. So for example, kanina, you have 5,000. So I have 5,000 names, but you only need 6. So 5,000 divided by 6 is 833. So kakount ako from number 1. Tapos count ako, number 833, siya yung number 2 ko. Then another 833, then that's my number 3. Another 833, ganon. No? So, or you can do it parang, pag mas maraming kailangan mo, every 10th name, siya yung pupuntahan mo. Every 20th name, ganon. No? So, that's systematic random sampling. Stratified sampling naman is you stratify them. So you stratify them into groups. So you divide them. Ang gusto ko kasi merong males, merong females. Or para fair, gusto ko merong galing District 1, meron din galing District 2. No? So you stratify them and then from each strata, each group, you randomly select. No? And then you can use the randomizer again. The next one is convenience sampling. Ito yung pinaka-favorite natin. So, a group is selected at will. At will, when you say hindi yung tipong type ko lang, ikaw. No. It's ikaw yung nag-choose ng characteristics. For example, sinong pupunta dito for this week? Doon ako pipili. So, that is convenience sampling. Purposive sampling is also a form of that. Purposive sampling naman, you purposely go to a certain area and you choose na ito, no? Volunteering is a form of convenience sampling. Sino may gusto, no? We know that with volunteering, the more you volunteer, the more compliant you are, the more mas madali kang kausap in your para dun sa study. So that's already there's a little bit of bias, no? Or chronological entry into the study as as they come along, sige, pasok, 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 pasok. Ipasok natin sa study. Or yung favorite nating total enumeration or total count. So again, I hope you realize that total count is not a sample size. The sample size is computed before your sampling method. So if the sample size is 6, but my sampling method is total count, then I will get the 5,000. But my sample size is still 6. The minimum sample size is still 6. Okay? Gets? So if you get total enumeration or total count, then that is convenient sampling. Next, cluster sampling. So the population is divided randomly into clusters. For example, barangays. Then X member from the cluster is chosen. So for example, no, I want to make a study in Zamboanga City. Then what I do is I will choose only from the barangays 10 kilometers away from Zamboanga City Medical Center. So, and then I choose how many members from those barangays. So this is basically cluster sampling. So this is not even stratified sampling because I did not divide them equally into groups. You just chose a certain cluster in one area. So that's cluster sampling. No? So basically the summary for sampling methods is the most reliable method is still the random sampling method. But it is not the easiest. The easiest is still convenient sampling. No? So you have to weigh the advantages and disadvantages of both. If you want a really more accurate, more precise, less biased type of result, then you choose a random sampling method. But to be truthful, you have to consider time, effort, cost, environmental factors. Like if I want to randomly select people all over Zamboanga City, there are areas which are quite dangerous to go to because they don't have roads or it's too far away and things like that. No, so then maybe that would not be such a good idea. So to summarize, so both obtaining the proper sample size and adopting the proper sampling design will definitely ensure more accurate and more precise estimates, leading to a valid conclusion. So choosing the correct sample size equation will lessen errors in hypothesis decision making. So for example, if you're doing case control, syempre you have to know how many cases and how many controls you want, diba? So you cannot use the equation for population size. Kasi yung population size mo gives only one number. So it tells you, oh sige, 20. So you don't know whether is this 20 cases or 20 control, diba? Because you don't take into consideration the variability of the probability of it happening among cases or happening among controls with your equation with the population survey. So you really have to know what you want based on your research objective, and then you choose the proper equation. And then after that, choosing the proper sampling design will definitely reduce your bias. Okay, so thank you very much for your attention with my very long lecture.
Oh, okay, Doc. Thank you. So I think, Doc,
You're welcome.
That's it. I think that concludes our day, po, Doc. Thank you very much for your time.
You're welcome. You're welcome.
And also to our participants, thank you very much for attending. We will see you again tomorrow for our research statistics lecture at 9:30 a.m. Thank you very much.
Bye.